Alright, so find x sum of all k long subarrays part 2. We already did part 1 using brute force. The problem is same. We are given nums and k is the window size. So for every window that is of this size that's possible, we want to find in them the top, x most frequently occurring element. So here in this window 1, 1, 2, 2, 2 and 1 are the most frequently occurring, and we want the sum of that. Similarly in this window 2 is occurring 3 times, and 1 or 3 or 4 are all occurring 1 time. In that case we take the maximum one, so the fourth one will take, and 3 times 2 and 1 time 4 will give us a sum of 10. That's the answer for the last window. Similarly, we will do the operations and get the answer. In the last approach for the part 1, we were doing for every window, we were calculating what we wanted. But in this one, we have to do it somehow that we don't really have to calculate it for every window. We just have to calculate it for the one that we are losing and the one that we are gaining as we slide the window. But how can we do that? Well, I was thinking of a problem that was LRU cache. I was thinking something on that route, but or even the median stream problem. But if we look at it, we what we really want, what we did in the last problem as well, last the part 1 problem. What we really did was we had the set right, a sorted set to keep, you know, the numbers in a ordered manner, right? So we had a pair of frequency comma number, and to make this we had a unordered map frequency as well. That was in comma n, just to construct this. So if you have not checked that out, please do. This one we are going to solve it in a similar way, but we are going to have two sets. Why two sets? Because for every window, as I slide the window, I'm going to lose an element, right? Uh, so that is going to be affecting the two sets. That is going to be the top set and the bottom set, or I should say this is going to contain top X element and this is going to contain the remaining element. Why we are having the remaining element? Well, that's because of scenarios where we are keeping track of just the top X element. If we are keeping track of just the top X element and we don't have remaining, then if I gain an element and lose an element, right, this is going to affect the numbers, right, that wasn't already kept track of, right? Because suppose we had 1 inside this window, or suppose we had some other element, some other example, let's take this 5, 5, 2, not this, 1, 5, 5, 2, 6, 5, 2, right? And we had a window of this much, 1, 2, 3, 4, 5, 5 size of case 5, and I'm here. I see that, or suppose this was 6. At this point I see that case 6, right? Sorry, x is 1 and k is 5. K is 5 and I see that I am only keeping track of top X, right? So I have 6 and 6 inside top X. Now if I gain this, my top X becomes 5, right? But I still keep it as 6 because I don't really know what number of 5 were already there, right? That's why we are going to have a remaining as well, so that we can effectively balance this out as I gain and lose elements. All right. So as I gain a element, I will update the frequency. Before I update the frequency, I will have a key, right? So I can delete all the old keys of that particular element, and I will update the frequency. I will add the number inside topics, no matter if I should add or not. I don't care right now. After adding, this becomes, this is ordered, right? So it will adjust itself, and I will see if top X is of size greater than X, then I will balance it out by pushing things that is not really needed from top X to remaining. Alright. Similarly, if I lose an element, I am essentially deleting it from both, adding it to top X, the updated count, and then updating or balancing it out. Right? That's what we are going to do this here. Let's code it up and see how it works. All right. So essentially, I am going to process it for the window. At least initially, all of them will go inside, uh, or actually no, all of the elements needs to be processed as I go, right? And then I will start losing and gaining element. So for initial window, I will actually before the window and all, I will have these declared. I'll declare it outside because I'm going to call another function so that I don't have to pass the arguments. This can be done in a couple of ways. Let me, since pair is going to be used right here, so let me define it so that I don't need to write it again and again. Sorry. And since it's long, let's define long as well. A set of pair of int comma int, that's going to be top X. Set of pair, it's going to be remaining elements, and I'm going to have a frequency map. Since this is going to just store the frequency and not the sum, so I don't require long here. Alright, so my window right border will be J, and for the initial stretch of the window I will just actually traverse J less than K. Till K I will traverse. So that's my window, and for every element I am going to process it. So I'll create a process set function. Alright, here I will probably process it, which means balance top X and remaining, delete the key, balance it, and then return back here. So I'm going to pass the number that I'm going to balance. I'm going to basically pass, since I'm going to increase the frequency or decrease the frequency, right? And I don't want to create two different functions for both of them, because except the increase of the frequency and decrease of the frequency, there is not really much of a difference because I'm balancing in both the scenarios. So I'll pass a Boolean value to determine if I'm going to increase the frequency or decrease the frequency. So here, since I'm stretching the window, I'm going to increase the frequency for every element. So I'm going to send true here, and I'm going to have to access X as well so that I can balance it out. Uh, Now that I have the window stretched, I will have a vector as well of our answer, and I will traverse along with my left border and my right border. So this time both will move forward, and I'll keep gaining and losing element. So I will gain the element for that. So I'll lose the element and then gain. So nums of I. This time I'm losing the element, so I'll pass false and X. I'll do I plus plus. Similarly, I'll do this for the gain. Alright, but I need to push the answer. Or should I push it here? Actually, I should push it here. Uh, for this particular window, I will add my answer here itself. So, sorry, this is not equal to 0. I don't know why I did that. Answer dot pushback. I'm going to have a sum, right? So let me declare the sum as well. So process set is also going to increase sum, and I will push it here for this particular window, for the first window, and then as I move forward, I will keep on pushing it inside answer, whatever the sum value is, because process set is going to take care of the sum as well. So by the end, I'll probably return the answer. Now process set is going to not return anything but just update the values by reference. So since things are global, all the variables are global, I just need to pass three of them. So process set is going to have first the number, then the boolean if it's an increment or a decrement. So is increment and the top x, whatever the value is. So I need to erase the keys if they're present in top x and remaining as well, right? So let me erase it first. What is going to be the key? It's going to be pair of uh, first the frequency of that particular number, so frequency of number, and the second thing will be number, so number. And similarly, I'm going to erase it from remaining as well if it's there. All right. But if I remove, suppose, okay, let's move forward and then update it later on, so that uh, that will be helpful for our understanding. So if it's an increment now, since I've deleted the key from both of the set, I'm going to increase the frequency, push it inside topics, balance it out, and then return. Alright, so essentially if it's an increment or a decrement, based on that I will either increase the frequency or decrease the frequency. So this, if it's an increment, I'll increase, else I will decrease. Uh, there might be scenarios where frequency is 0. In that case, I shouldn't really push it inside topics, right? So if frequency of number is equal to 0, then erase it from the frequency itself first. So frequency dot erase number, and at this point, if frequency dot find if number exists still, so this must mean that it is positive, greater than 0. If that is the case, so this is num and not nums. If that is the case, then I am going to insert it inside topics. Alright, frequency of num comma num, and at this point I will start balancing it. So what can be the scenarios to balance? Right? I can create a different function for this, but should I? Actually, it's fine. Let's create it here itself. So balancing can have a couple of cases. So if topics has elements has elements greater than x, okay. If topics has elements smaller than x, or if it's equal to x, then I need to make sure that only the one that is, if it is equal to x, then we need to make sure that the bottom of the topic set and the topmost of the remaining set, which means the smallest in topics and the largest in bottom or the remaining, then if they are equal in terms of frequency, then I should take the bigger one, or the what should I say? Like in this example, 4 is what I need to take, right? Since 3 and 4 are of the same frequency. Suppose 3 is in topics and 4 is in remaining. So 3 is at the bottom of topics and 4 is at the top of remaining set. Then I am going to take 4 and swap it with 3. That's called balancing if topics is equal to has elements equal to x. Alright, so this three cases needs to be done. First, let's do uh, the first first case. So case one is topics dot size is greater than x. So if it's greater than x, then I have to get the most bottom frequency and the number, so that I'll get it inside bottom frequency and bottom x. And since the topic set is sorted, I will get it from the dot begin function. So here I will insert it inside the remaining set, because I have to transfer one element from topics inside remaining. Alright, so I'll copy this, and then I will erase the key from topics, and so this is the case for topics. So right now I'm not even touching sum. I will touch it at the last. Right now I'm just balancing it. If the second case states that topics dot size is smaller than x, in that case, what should I do? I should transfer the elements from remaining if there is, otherwise I can't do anything. So I have to enter here only if there is some elements inside remaining. Alright. And what should I do? I shall transfer the topmost element inside remaining to the topics. So I will get the topmost from remaining by the dot r begin because I have to take it from the last, right? So r begin is what we have in C++. So top remaining frequency and top remaining number is equal to, I will get it from remaining dot r begin. So I will do the same thing, just opposite. Erase it from remaining, and the pair will be this, and insert it inside topics. Okay, alright. And finally the case where they're equal. So if top x is, or actually top x dot size is equal to x, and so at this point what should I do? Again the same thing. uh, I want to check the topmost of remaining, bottommost of topics, and what should I do with them? If topics, if top of remaining is equal to, in terms of frequency, if they are equal, bottom of uh, topics, if they are equal in terms of frequency, then swap if the one in remaining, if the remaining number is greater than the top x number. Alright. If they are not equal from the start itself, if they are not equal, then swap if the frequency of remaining is greater than frequency of the number. Alright. So essentially I am entering this particular loop or this particular condition only if there is something in remaining. So I will have a check like this, and at this point I will check, or I'll get the bottom x and the top x, or the bottom in top x like this, and the top in remaining like this. Finally I will check for this particular two conditions, that is bottom x frequency, if it's smaller than top remaining frequency, or so if this is true or this is true, only then swap, or bottom x frequency is equal to top x frequency, and the number in top remaining is greater than bottom x, then it's good to swap. How are we going to swap it? I'm going to erase it from remaining Uh, Actually, yeah, I'm going to erase it from remaining, insert inside topics, and similarly, I'm going to erase it from topics and insert it inside remaining X, isn't it? Let's arrange it and update it. So inside topics, what am I erasing? I'm erasing the bottom X, bottom frequency and bottom X, and I'm inserting that inside bottom X or inside remaining. Yeah, actually this is it. This is good. Inside top X, I'm inserting the bottom top, and inside remaining, I'm erasing that. Remaining insert bottom frequency and erase it from top. This is good, and that's it. This is void, so I'm not really returning anything. Now comes the part where we update the sum. We want the sum for top X, right? Whatever element exists inside this. So in that case, I will really update wherever I am erasing or inserting inside topics. I'll update the sum. Uh, if I'm inserting, I will add. If I'm erasing, I will delete. So before erasing, I will check if I am really erasing anything or not. Because erasing might be something like the key doesn't even exist. In that case, I don't really need to update the sum. So I'll check that first. So if this key exists inside topics, only then update the sum by removing it. How many number of times? Frequency number of times. Alright. I'm inserting it here, so I'm increasing it by this number of time. I am erasing it here, so I'm subtracting it this number of times. Increase, so increase. Decrease, so decrease. So here I need to be careful. Actually, I am decreasing this many number of times, so let's be careful and update this accordingly. And let's check here, it's fine. This is top remaining frequency and top remaining number, and this is bottom frequency into bottom X. And this is erasing, and we are also inserting here. So this is good, erase is good, this is good, this is good. I think this looks good. Alright, and since we are updating the sum, actually I should have also taken as I should take care of the overflow if there is whenever we are updating sum. Alright, this is okay, this is okay. Okay, let's see now if this works. It's a long piece of code. There will be a lot of errors. There should be bottom X frequency. Oh, my bad. This should be bottom frequency. Or you know what? Let's update it here instead. Okay, let's see now. Bottom X frequency, bottom X frequency, topics. But there should be top remaining frequency, and yeah, this should be bottom frequency, or it should be bottom X frequency. Alright, okay, this works. In terms of time complexity, this will be close to of n log n because we are really iterating and processing insertion and deletion as log n, and we are doing it for every node. So that's of n log n, and or actually not even n log n, uh, of n log k, since the maximum set size is going to be, actually it can be of n log n instead, because the window can be of some size, but we are also having remaining, right? Uh, which depends on k. Yeah, I think of n log k should be it. And in terms of space complexity, it will be O of n, since we are going to have a couple of O of n frequencies. And that's it, that's the problem. Thanks.